When it arrives closest to the sun, the Earth would be on the opposite side, and we won't be able to observe it. But that's exactly the time when it could do a maneuver to slow down and visit us. And one wonders whether this trajectory was designed by some extraterrestrial intelligence.
By late 2025, 7 cosmic visitors will be approaching Earth. A convergence so rare that even the AI-powered telescopes are struggling to keep up.
From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet.
This isn't just another set of light shows in the night sky. It's a coordinated arrival of interstellar dust, tail disconnections, and chemical fingerprints unlike anything ever recorded.
NASA scientists first spotting Threei Atlas in July, just a tiny speck of light sailing through a sea of stars, a mind-bogglingly rare visitor from outside our solar system.
But here's the real twist. One of these visitors is leaving behind something no scientist can explain, and when you hear what it is, you'll be stunned. The 7 visitors and the surveillance of the sky. By the second half of 2025, 7 massive comets will enter the inner solar system in just 6 months. Not fragments, not pebbles. Real, glowing giants with tails that stretch for millions of miles.
Actually, a dense cloud of dust that somehow did not produce until recently a tail.
And the probability of this happening by chance? Less than 0.5% per decade. Some simulation models even push it to once in 1,000 years. The numbers don't lie. The artificial intelligence running Monte Carlo simulations for orbital clusters flagged this event as an anomaly. Something that shouldn't be happening. And yet it is. And that includes Threei Atlas, a confirmed interstellar comet, only the 3rd one we've ever recorded.
Threei Atlas, a 3rd ever interstellar object observed from Earth, currently racing through our solar system.
This isn't just a tourist from the Oort cloud. It came from outside our solar system, bringing with it molecules no one has cataloged before. Even the pros are shaken. Pan-STARRS and Atlas, 2 of the most sensitive robotic sky surveys ever built, have been logging thousands of celestial objects for years. But nothing like this. 7 major comets, all inbound, all clustered, and the alignment? Tight. All of them arriving within a single Earth season. It hasn't happened in over a century.
It's moving too quickly to have come from the outer reaches. It's from someplace else.
The last time we came close was 1910, when Halley's Comet appeared alongside the Great Daylight Comet, 1910A. But even then, just 2. Now it's 7. And every night, these arrivals are being tracked. Not by people, but by high-altitude robotic telescopes sweeping across Hawaii, Chile, and South Africa.
NASA-funded telescopes have their eyes on the sky all the time.
These systems use artificial intelligence-enhanced optics to scan millions of pixels per image, night after night. They're trained to spot a single moving smudge, drifting 1 pixel to the left or right. And when they do, a global alert system lights up. But here's the twist. The machines are falling behind. The volume of inbound data is so overwhelming, astronomers have had to step in.
It turns out that the 2 directions of the WOW signal and Threei Atlas are aligned.
Manual reviews are up. Some alerts are being delayed. It's a system never meant to handle this much noise. Tail physics, solar storms, and celestial myths. What many don't realize is that as 7 comets barrel toward perihelion, the space around our star is about to light up in ways we haven't seen in a lifetime. Here's why that matters. As a comet nears the sun, its icy nucleus superheats. The frozen core turns into a cosmic steam engine, blasting out gas and dust to form a glowing tail that stretches for millions of miles. But sometimes, the sun doesn't just heat it, it attacks. Enter the tail disconnection event. A coronal mass ejection, a solar eruption loaded with charged particles, slams into a comet's tail. The result? It snaps off, gone, like a broom handle shattered mid-sweep. And yes, this has been caught on camera. In 2007, NASA's stereo mission filmed Comet Encke losing its tail in real time. Now imagine that happening with 7 active comets flaring up in the same solar season. Some heliophysicists are calling this the perfect stage for multi-comet tail severances.
The comet's path will take it past even more of our robotic explorers.
Rare events that could unfold only hours apart. The physics behind it are explosive, and while the visuals might be breathtaking, they could also pose potential risks. A surge of solar activity interacting with multiple comet tails at once might disturb space weather near Earth, disrupting satellites, or even affecting our planet's magnetic field. But comets weren't always viewed as scientific curiosities. For most of human history, they were omens.
And it's only the 3rd object ever confirmed to have come from interstellar space.
Ancient China called them broom stars. believed to sweep away dynasties. Roman historians claimed that Julius Caesar's funeral was marked by a blazing comet, seen as proof of his ascension to godhood. Across Polynesian islands, Arctic tribes, and Mesoamerican temples, comets were interpreted as messengers, often foretelling upheaval or rebirth. What once sounded like myth now echoes with uncanny resonance. Why? Because some of those comets might have brought life. That's not hyperbole. Comet 67P, analyzed by the Rosetta mission, carried glycine, an amino acid, and phosphorus, a building block of DNA. If those ingredients came from our own solar system, great. But what if they came from beyond? Which brings us back to Threei Atlas. Its coma is loaded with carbon dioxide. Not water, not ice, something alien. Orbital crowding, cosmic clocks, and ancient echoes. So now, researchers are asking the unthinkable. Did something trigger these comets to approach? At the University of Maryland, one research group proposed a bold hypothesis. What if this isn't a coincidence at all, but a delayed aftershock of a massive event? A rogue object, maybe a dark planet, or even a failed star passing through the outer Oort cloud centuries ago, could have scattered icy bodies like billiard balls. Their arrival in 2025 might simply be the long, slow fallout. That sounds like a minor speculation, until you hear this. In 2019, teams using data from the Gaia Space Observatory spotted microdeflections in stellar movements. Subtle, but consistent. It led to the proposal of a Mars-sized object, dark and undetectable by telescopes, moving through the Oort cloud's distant fringe. Not yet confirmed, but not ruled out either, which brings us to a haunting parallel. Across ancient civilizations, stories survive, cryptic references to years of many tales. The Popol Vuh, a Mesoamerican text, speaks of a time when the sky danced with fire, shortly before a great flood. Chinese records from 88 BC mention 5 comets within 100 days, calling it the season of sky dragons. Aboriginal oral traditions describe lights streaking across the heavens, followed by environmental chaos. Could these be fossil memories of previous comet storms? Back in the present, astronomers have a more technical problem, telling the comets apart. With multiple tails, overlapping dust trails, and outbursts occurring simultaneously, the risk of misattribution is real. A gas cloud recorded as coming from Atlas K, one might actually belong to Lemon, or even the interstellar Threei itself. It's becoming a full-time job just to tag and sort the footage correctly. But here's the new worry: orbital interference. We're not talking about collisions. Space is still massive, but gravitational nudges, overlapping electromagnetic wakes, and tail-crossing interactions are all in play. Some comets might brighten or dim unexpectedly. Others could split. There's even speculation that fragments might spawn new, smaller comets right in front of our eyes. In essence, the sky over Earth won't just be active, it'll be unstable. And if history really does echo, then maybe those old stories weren't just myths, maybe they were memories. The race for sky control. Who owns the comet data? Behind the breathtaking visuals and interstellar dust trails lies a quieter, more strategic shift: the privatization of the sky. While most people focus on the spectacle of incoming comets, a growing number of researchers are sounding the alarm over something else entirely: who controls the machines that track them? Here's the setup. The vast majority of the world's comet detection now comes from automated sky surveillance networks. Some are public, like Pan-STARRS in Hawaii, or the European Space Agency's Fly-Eye project.
Looking at the life cycle of certain patches of the sky, we're also looking to see other pulsating stars, things like that.
But more and more data is now flowing through private space companies, tech contractors, and commercial observatories whose data pipelines aren't always shared. Take NEOSM, the Near-Earth Object Surveyor mission, launching soon. It's public, on paper, but much of its data relay infrastructure is run through commercial partnerships. Then there's China's SkyEye network, a classified deep space optical tracking grid rumored to have comet tagging capabilities rivaling the West. And let's not forget SpaceX's Starlink constellation, now being used by third parties to calibrate optical distortions in deep field observations. So what's the problem? If access to sky data becomes limited by national security, corporate interests, or classified protocols, the global scientific community could lose the ability to study future anomalies in real time.
But cosmic radiation, which permeates all of deep space, is another ever-present challenge to human health.
Some astronomers are already seeing delays in raw observational data. Others suspect that certain detections might not be shared at all, especially if a comet's trajectory or chemical makeup raises deeper questions. And that brings us back to Threei Atlas. If even a handful of its interstellar dust particles fall to Earth, who gets them first? Which lab? Which country? Which military? The race isn't just to observe the skies anymore. It's to own the first fragments of alien matter.
He's talking about this Threei Atlas as actually being literally an alien ship.
Threei Atlas, the alien wildcard with a coma the size of the sun. Out of the 7 incoming comets, 1 stands apart, and it's not even from around here. Threei Atlas, short for Third Interstellar Object Detected by the Atlas Survey, is a wild card that has scientists watching every pixel it moves. Its coma, the green glowing cloud of gas and dust around its icy core, is roughly 700,000 kilometers wide. That's nearly half the diameter of the Sun.
Threei Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
No comet in recent history has come close to that scale, and none with this kind of chemical footprint. Because when researchers aimed the James Webb Space Telescope, along with ground-based giants like Gemini South and Palomar, what they saw stunned everyone. Instead of the usual water vapor and carbon monoxide, Threei Atlas is erupting carbon dioxide, and lots of it. 8 parts carbon dioxide to every 1 part water. There's no comet in the catalog with this ratio. One theory says this object was born in a system far colder than ours, so cold that carbon dioxide condensed more efficiently than water. Another theory suggests a sealed crust, like an ancient pressure lid, is trapping water ice and letting only the carbon dioxide escape. Either way, it defies every model we have for comet behavior. But things get even stranger when you factor in the dust trail. Using N-body simulations, astronomers from the SETI Institute and NASA Jet Propulsion Laboratory trace the path of its debris. After its closest pass to the Sun, its perihelion, the dust plume of Threei Atlas is expected to cross Earth's orbit by mid-2026. There's no danger of impact, but the possibility of interstellar grains falling into Earth's atmosphere, very real. Now, balloon missions, stratospheric aircraft, and high-altitude radar stations are on standby, because if even one microscopic particle survives re-entry, it could carry molecules, isotopes, or chemical chains from another star system. A new term is catching on: interstellar forensics, and the lab is Earth's upper atmosphere. Artificial intelligence glitches in deep space when the machines get it wrong. With comet detections now relying almost entirely on automated telescopes and deep learning models, the unspoken risk isn't just about what we might miss, it's about what artificial intelligence might misread. And it's already happening. In early 2024, a false positive alert triggered a brief global stir. An autonomous node in the Vera C. Rubin Observatory's Sky Mapper system flagged a massive object crossing the ecliptic. It had all the signatures of a comet: magnitude, motion vector, and a developing coma. Within hours, alerts were relayed to observatories in Australia, Chile, and even a telescope array in Namibia. But when the data was manually reprocessed, it wasn't a comet. It was a fast-moving satellite flare, distorted by lensing effects and camera pixel noise.
This was a really dramatic difference from what had been seen previously.
A single cloud layer over the Atacama Desert had warped the optical input just enough to fool the artificial intelligence into building a false narrative. One convincing enough that multiple teams believed it for nearly 12 hours. That may not sound like a crisis until you remember what's coming. In late 2025, with 7 active comets, interstellar objects, and real-time meteor tracking underway, the volume of raw sky data will spike by over 400%, and artificial intelligence will be forced to triage. It will decide which object gets flagged, which one is ignored, and which anomalies don't make the cut. Some astronomers are now proposing a chilling idea. What if a real anomaly, a fragment that doesn't belong, a flash of unknown origin, is dismissed as noise? As reliance on artificial intelligence deepens, the sky becomes a black box. We see what the model lets us see. And as we move into this era of digital discovery, the real question might not be what's up there, but what's being filtered out without us even knowing. Comet interference and the ghost signals in Earth's atmosphere. As comet traffic thickens in late 2025, researchers are bracing for something that sounds like science fiction, but is rooted in physics: electromagnetic interference from overlapping comet tails. Here's how it works. Each comet that swings near the Sun forms not one, but 2 tails, a dust tail and an ion tail, made of charged particles.
This is actually a dense cloud of dust that somehow did not produce until recently a tail.
These ion tails aren't just glowing gas. They're electrically active, shaped and whipped around by the solar wind's magnetic field. And when a solar flare or coronal mass ejection hits, these tails pulse, ripple, and sometimes disconnect entirely. Now imagine 7 ion tails, all in close proximity, all reacting to the same solar storm. We've never observed this many interacting in such tight succession. Plasma physicists are calling it a magnetic soup, where overlapping ion trails could start to affect Earth's ionosphere, the very region where satellite signals, global positioning systems, and even shortwave radio bounce. Already, observatories in Chile and Greenland are preparing very low-frequency monitoring stations to listen for anomalies. These are faint electromagnetic whispers generated when charged particles from a comet tail interact with Earth's magnetic field. And in the past, these whispers were dismissed as noise, but not anymore. A recent paper from the Massachusetts Institute of Technology's Haystack Observatory found strange electromagnetic patterns during comet Leonard's Pass in 2021, coinciding with temporary signal drops across several upper atmosphere monitoring stations. The cause, possibly tail ion interference. With Threei Atlas, a hyperactive comet shedding over 60 kilograms of dust per second, and 6 others behind it, the question isn't just what we'll see, but what we'll hear. Could overlapping tails trigger phantom echoes in Earth's electromagnetic field? Could this comet static interfere with deep space communications, or worse, mask a real signal from somewhere else? Scientists are now deploying wideband receivers, tuned to search for ghost signals, bursts of unnatural data that might show up during peak tail overlap. Stratospheric fallout. Will these comets change Earth's sky chemistry? As the 7 comets begin their solar flybys, the focus has been on their light shows, tails, and interstellar dust. But a quieter concern is building among atmospheric scientists. What happens when their microscopic particles actually fall into Earth's atmosphere? This isn't speculation, it's already happened before. In 1998, after the Leonid meteor storm, sensors detected a spike in noctilucent clouds, the wispy high-altitude clouds that glow electric blue and form only under rare conditions in the mesosphere. Follow-up analysis revealed increased traces of meteoric sodium, aluminum oxides, and even organic fragments, all consistent with cometary origin. Now multiply that. By mid-2026, Earth is expected to intersect the extended debris trail of Threei Atlas, the interstellar wildcard. With its extreme carbon dioxide emissions and hyperactive dust ejection, over 60 kilograms per second, the amount of fine particulate matter drifting toward Earth could be orders of magnitude higher than past storms. And here's where it gets strange. Researchers at the University of Leeds are modeling how this incoming dust, rich in carbon compounds, exotic silicates, and possibly nitrile groups, might trigger unusual chemical reactions in the stratosphere. Some fear temporary disruptions in ozone regeneration. Others are watching for increased noctilucent cloud formation, or worse, conditions that could seed artificial weather patterns. It's not just science fiction. In 2001, during another intense meteor event, Earth's mesosphere showed infrared flashes that were never fully explained. Just a brief spike, then gone. And now, balloon-based platforms like Picture-C and Astros are preparing to float above 70,000 feet, watching for similar flashes as comet debris enters. Could this trigger new climate microevents? Would localized upper atmosphere changes alter jet stream behavior or affect satellite signal clarity? No one knows for sure. So what do you think? Is this just a freak alignment of ice and rock, or is something bigger at play here? Drop your thoughts below. We read every comment.